Okay, so we got one more problem. It's from CSIR.NET, and for this PD, again homogeneous heat equation, one dimensional, between zero with the boundary condition 0 t equal to 0 and 0 pi t is 0. That's simply at temperature at both the ends we have given 0, and we have initial condition imposed on this, which is nothing but sine x plus sine 2x. Okay. And now they're asking which of the following is true. That is, uxt goes to 0, st goes to infinity for all x belonging to 0 to pi. And then the same thing multiplied by sometimes t square and then e power t, e power 2t. Fine. And then it says e power t, uxt is bounded for all x belonging 0 to pi. Okay. So I have to solve this. Okay. Solving this question here, it's quite easy. Now, any differential any PD whenever it is given, just compare this with standard equation and try to find your c square and your f of x. Sorry, I think I made a mistake here. It's always here. Okay, equal to del u by del t, and then ux0 equal to your f of x. So if you compare your standard equation with this, you get f of x to be equal to sine x plus sine 2x. Okay. And our c is 1. Okay. So now we will feed into the system. The solution of this equation is given by uxt equal to summation n equal to 1 to infinity dn sine n pi x upon l e power minus c n square pi square upon l square times t. Okay. Now our goal is to find dn first. Okay. So dn is nothing but 2 upon l and integral 0 to l f of x into sine n pi x l sine n pi x by l dx. Now let us equate this. Now if you look at the problem, okay, here, then your length is pi. Okay, so L here is pi basically. Okay, so I'll feed here. So I'll be getting basically 2 by pi integral 0 to pi f of x is sine x, okay, plus sine 2x. Then here a lot of cancellation will happen basically. So this, if I put here and pi x upon L, okay. So this L here is pi, so pi and pi will get cancelled. We ultimately just get nx. Okay. And now I'll separate this equation and I get this integral 0 to pi sine x into sine nx dx plus then 2 upon L, 2 upon L, 0 to L sine 2x into sine nx dx. Okay. This is my dn. And now, as we have already seen, that this quantity is always 0, okay, except when they are equal. And this sine x should be equal to sine nx, so it will be equal for n equal to 1 here, and for n equal to 2, this will be equal. So basically, we will get just two values, d1 and d2. When I put d1, then this quantity will give me here 2 by pi, and this quantity, entire quantity, will give me pi by 2. Okay, we have already discussed this in our previous video. And then again, it will be here 2 upon pi. Oh, I'm sorry, let me write down here pi. By mistake I wrote here L. It is pi, okay, because L is pi. Yeah. And so, and this part will become 0 for d1. So ultimately I just get 1. And now on the same lines, if I find d2, then this quantity will become 0, because here I'll get sine 2x, okay, and here it is just sine x. So that part will be again 0, and only this part will give me, right, the second term will give me 2 upon pi, and then pi by 2 it will give me, so it will give me 1 again. Okay, so d1 and d2 is 1. And now just plug in everything in this big equation, star equation. Okay, so after doing so, we get uxt equal to, first you write down the formula in your reduced form. So dn into sine n pi x gets cancelled, you just get nx here, and e power minus c just 1, so it will be basically n square times t. Okay, and now if happened, so you just open this, so you get d1 sine x into e power minus n square, which is 1, so that's t, and then d2 times sine 2x times e power minus 2 square 40. Okay, and now d1 and d2 both are 1, so ultimately I get sine x into e power minus t plus sine 2x into e power minus 4t. Okay, that's my uxt. Okay, and as the rule of equation, so for option A, okay, I think I told you even in the last video that uxt always goes to 0 as t goes to infinity. Okay, you don't have to check even. Even if you check, see, you are basically getting limit t tends to infinity uxt. This will be equal to limit t tends to infinity sine x into e power minus t plus sine 2x into e power minus 4t. Okay, so both this e power minus t goes to 0, and here sine x is bounded, here sine 2x is bounded, and e power minus 4t goes to 0. So this entire quantity becomes 0. Okay, so option A is true. Option A is true. Now comes option B. Option B says that t square times u of xt also goes to 0. Okay, as t goes to infinity. As t goes to infinity. Let us check the validity of this statement. Okay, whether it is true or not. So our uxt is nothing but sine x into e power minus t plus sine 2x e power minus 4t. Now I'll multiply this by t square. So I get t square into u of xt will give me t square sine x into e power minus t and plus t square into sine 2x into e power minus 4t. Now I'll take the limit. Okay, so limit t tends to infinity, t square into uxt will be equal to sin x should be out of the picture now. And then limit t tends to infinity, t square into e power minus t plus sine 2x will again come out because the limit is with respect to t. Okay, so t square times e power minus 4t. Okay. Now we have to solve these two. So we can simply check what we have here. Okay, so I'll change the ink for this. Let us say I'm finding this limit t tends to infinity. Okay, so t square into e power minus t. So if I put here infinity and if I put here infinity, so this is basically 0 into infinity, that's an indeterminate case. So to apply L'Hopital, we have to do some manipulation. So I'll go with this. Okay, I just take e power minus t down, so I get this. Now it is infinity by infinity. So by L'Hopital, I get limit t tends to infinity is 2t upon e power t. Again, this is infinity by infinity. So can apply L'Hopital and you get limit t tends to infinity just 2 upon e power t, and that will give you 0. Okay. And now similarly you get another one. Okay. Limit t tends to infinity. Okay. T square into e power minus 4t. This quantity again will give you 0. Okay. So limit t goes to infinity. Okay. T square upon e power 4t. It's again infinity by infinity form. So I'll apply L'Hopital and get limit t goes to infinity, t square will be 2t, and e power 4t will be 4 e power 4t. Again, infinity by infinity. So again apply L'Hopital, and you see this turning out to be 16 e power 4t, which will give me 0. Okay, so this entire quantity goes to 0 into sin x will again 0, and sin 2x will again 0. So this whole quantity goes to 0. Okay, so ultimately this is 0. plus 0 equal to 0. Okay, so even option B is true. It says that limit t square u of xt goes to 0 as t goes to infinity. And now we run for option C. So option C says e power t and then uxt is bounded. Okay, let's check the validity of this statement. Okay, so our solution was sin x e power minus t plus sine 2x and e power minus 4t. Okay, now let's multiply by e power t. So we get basically just sin x here and then e power minus t and e power t will give me 1, and this sine 2x quantity will give me e power minus 1 minus 4 will give me minus 3t here. Fine. Now I have to say it is bounded or not, so simply just do this. And now clearly you can see applying triangle inequality, you get sin x plus mod of sine 2x into e power minus 3t. Okay, now this will simply give me this is less than 1, and this quantity will come out basically to give you this sine 2x times e power minus mod 3t. Now this is again bounded and this is again bounded. Okay, so basically this quantity is less than or equal to 1 plus this is again basically bounded by 1 only, and this quantity is again bounded with 1. Okay, so e power t into u of xt is bounded. So even option C is true. We got this thing bounded. Now we have to run for option D. Option D is nothing but e power 2t times uxt is bounded. No, I'm sorry, I think it tends to 0. Forgot it. Okay, tends to 0 as t goes to infinity. Let us check the validity. So your uxt is nothing but sin x e power minus t plus sine 2x e power minus 4t square. Now if I multiply e power 2t, then I get this sin x, and then it will be e power t plus sine 2x and I'm sorry, it's not 4t square, this is just t. Okay, this is just t, yeah, correct. Now, so it will be 2t, 2 minus 4 will give me here minus 2t. Okay, here the problem is only with this term. So this is bounded, that's true. Even this is bounded, this quantity is also bounded, but e power t is not bounded. Okay, so you can simply say e power t, okay, is not bounded. So basically, your this entire quantity will not be bounded. Okay, so if it is not bounded, and then if you take limit t tends to infinity, okay, e power t, then this does not go to 0. So basically, e power 2t into uxt does not go to 0 as t goes to infinity. Okay, so option D is incorrect. Okay, option D is incorrect. Now go back to the solution. Then here option A was true, option B is also true, option C is also true. Option A is always trivially true, okay, because for a heat equation, this temperature goes to 0 as t goes to infinity. Okay, so that is absolutely true. Okay, thanks for watching. See you in the next video.